All right, my name is Carl Pascarella, and this is an overview of the individual project. And the topic that I did is the finite element analysis of a 3D printer. To start things off, all of the parts were modeled out using SolidWorks, and once they were all individually modeled, they were brought together as an assembly, which can be seen here. This is the extruder assembly from a Creality CR10 printer, and everything was lined up so that there's no interference with the parts. And it was all saved as an IGS file, so it could be used in ANSYS. Going over to the ANSYS, we have all of the different projects here in one big file. This bottom row is just the heat sinks, and this top one is the extruder assembly in different configurations. For each of these, the engineering data was selected, and the three materials that make up the extruder were selected, which are aluminum for the heatsink and connecting rod, brass for the heat block and nozzle, and stainless steel for the two screws. Opening up the geometry for one of them, here we see the completed extruder assembly, and all of these are marked as a solid rather than a surface. What was occasionally happening was the solids would come in as a surface due to a light, interpretation error between the SolidWorks file and the IGS one, and it would be viewed as a surface instead and would not be processed at all. This had to be just redesigned and brought back in until it was working right, but this is it in fully working order. So going over to the models of these, got a few of these open. For the steady state thermal, the extruder assembly was brought in, the materials were selected, so the aluminum would be here, stainless steel for the two screws, and the brass for the rest. Then a mesh body sizing was added, which brought the element size down to 0.0025 meters. This is the smallest allowable mesh that can be processed with this free license. A temperature was added to the center where the heater core is. This was set to 200 degrees, which is the typical melting point of most PLAs, and it's what you'd usually see in a 3D printer. Convection of 40 watts per meter squared was added to all the remaining surfaces to sort of represent the fans that blow on this assembly. And finally, the solution items were added to measure the temperature, heat flux, and some temperatures at important points. This is the overall temperature distribution. You can sort of see it like rainbows out. The heat flux, a lot of heat's moving through here. The rest is fairly stable, but that does change when it's a transient system. The probes were also added at the nozzle and around where the sensor is. This shows the difference between how the system would read, the temperature to the rest of the 3D printer, saying, hey, the nozzle is this hot, versus how hot the nozzle actually is. And there seemed to be about a 10-degree difference between them, which, depending on what filament you're printing in, can be significant. Several heat sinks were also tested. This one is just the stock one. They were all set to the aluminum material with a default mesh to keep things consistent. A temperature of 120 degrees was applied to the bottom, and a convection of 40 watts per meter squared was added to all the other surfaces. And the temperature minimum and average were taken, as well as the reaction probe to measure how much heat was actually dissipated by it. And a bunch of different designs were tested, testing different, fin sizes, number of fins, just to see what might work. Finally, a transient thermal system was made using the full extruder assembly. This was set up in the same way, using the same assembly, with the same mesh, the minimum body sizing, same materials, and the same temperature and convection applied to all of it. This shows the temperature as it's effectively from a cold start and how the heat transfers through it as it starts to heat up initially. Two sensors were also added, or probes rather, for the nozzle temperature and the sensor temperature, and these were both graphed and compared against each other to show how the heat is basically supplied to the rest of the system as it starts to heat up. That is about all I have for this project, and thanks for watching.